Hi everybody, so I'm going to show you how to use the phet simulator to do a cool little lab where we can launch something at various angles at a given launch speed and look at how far it goes. And you're going to make a plot of how the range varies with the angle of launch. And then you can do some analysis where you're going to bring in vectors. So it's good practice and even some kinematics. There are some little quirks to this, so that's why I want to walk you through some of the things. And I'll be going back and forth between this and the lab sheet so you know what's going on. So I'll have a link in Schoology that'll take you to this site, this phet site for projectile launcher, and hopefully it's pretty easy to launch. You don't have to do anything with flash or anything like that. So when you get to this, you're going to go to the lab, click on the lab. So on the front of your lab sheet, okay, you have that in front of you. I'm not going to flip over to that right now on the screen because it's just easier right now. You're going to look at the settings, okay? So the default settings are pretty fine. We don't want any air resistance. We want gravity the way it is. You can change the diameter of the object. It doesn't really matter. That's up to you. And if you look on the lab sheet, so maybe I should refer to that right now. Okay, you have these settings. So you're going to want to change the height of the initial height is not going to be at ground level, and I'll explain why. So we're going to set it to 1 meter, and I'll do that in a second. There's a launch speed. You can choose whatever launch speed you do, but don't choose it too slow. Don't do it too high. Just find something, but record it in this space right here. Okay, the initial launch angle is going to be 0, and we already said we're talking about the air resistance. So the directions are right down here, but I'm going to talk about them looking at the site. Okay, so to change the height, there's this little plus sign on the cannon, and I'm going to raise it till it's 1 meter. I can move the angle, so my initial angle is going to be 0 degrees. So the reason I can't do 0 degrees when we are at the ground level. I'm having a hard time getting this exactly on 0. It's weird. Okay, there we go. So I have a speed. The default speed FIC is 18 meters per second. I have no problem with that. Maybe I'll just drop it down to 15. Again, your choice. Just don't go way too slow on that one. All right, so what I want to do is if I look at the data table on the back, I'm going to find the range. Okay, using a rangefinder, and then for every other angle, every odd multiple of 10, you're going to time how long it's in the air. So the rangefinder is right up here. So, and the key thing is we need to find the range when the cannonball is at the initial height of 1 meter. So let me do an example. I'm going to switch the angle. So let's say I just choose a 40, I'll just do a 28 degree angle, and I fire it. So I do that, so I press the button there, I fire it, and there it goes. So what I want to find out is not how far away it landed when it hits the ground, because the height of where it hits the ground is different than the initial height, and I want to have a symmetry there. So I move this rangefinder so that the height is as close to 1 meter as possible. So I'm moving it. I'm too high. I'm getting closer. And you might not be able to get it exactly on 1 meter. Let me see if I don't know why it's gone away. Let me try it on my desktop. I haven't had an issue with this before. Oh, I see, because I got to have it right on one of the dots. You have these little dots there. And so my height is 1.25. Let me go to this dot. So the height is 1.53. So here I'm going to have to guesstimate what the range is. So the height here is 1.25, and I see that the range is 18.54. Okay, so, and if I go to the next dot, which highlights it, we're at a height of half, which is 19. So I'm going to say it's between 18.54 and 19.87, and it's probably closer to the 18.54. So I might call it 18.819. So that's going to build in some uncertainty. Now, you're not going to record that now because we're not going to test 28 degrees, but that's a little bit of the work that you have to do to figure that out. The second thing you're going to do is, let's say you fire it at 30 degrees, and I want to time it. So you're not going to actually have to have a stopwatch here. So I fire it again. I can erase the previous one. And so again, I want to find where is it when it's at a height of 1 meter, or as close as I can get to that. So I got to go guesstimate it right there. But notice that the time is given for me, so I can record that based on the rangefinder. Okay. The alternative to doing that is I could try to use this thing to measure where the height is at 1 meter, but you know what, that's not worth it because I can't get the range easily that way. So anyway, you're going to alter this angle all the way up to 90 degrees. You're going to fill out the data table accordingly. Okay, so let's look at what else we have here. So again, I've explained all that. We're going to fill this out, so put in the angles. Make sure you put units in there. The uncertainty and range is based on that little analysis we talked about. The gray areas here, you don't have to put times. So just for 10 degrees, 30 degrees, 50, 70, and I believe 90 degrees. So once you have all that data, you're going to go to a Google sheet, and you're going to plot range on the y-axis, right? And the symbol for range is going to be x, even though it goes on a y-axis, and then versus angle. The symbol for angle is theta, and that's going to go on the x-axis. If you don't remember how to do graphs on a spreadsheet, you have tutorials somewhere in the references folder, okay? Or let me know, and I can make that more available. Put in error bars based on your uncertainty and range. You're going to need to print the graph, or if you got Cami, you're going to have to upload it. But you have to draw best curve, and you can't use the spreadsheet to do that. You're going to actually have to do that by hand. It's going to be a different type of curve. Okay, and then do this one. Place a mark on the graph that surely gives the angle with the greatest range. That's one of the things we want to figure out here is at what angle do you get the greatest range. Then for further analysis, you're going to take that launch velocity, whatever it is. Remember, you're launching it at some angle, so it's represented by this vector right there. So I've drawn a vector triangle with the components. So let's say you fire this at 18, and this angle is 30 degrees. I want you to find how much of that velocity is horizontal, how much of that is vertical, and fill in the tables right here. The launch speed is going to be the same. You should have kept that constant. These will change. Then I want you to find the maximum height. That's a kinematics problem now. We should be comfortable. So let me just point out a few things about maximum height to help you out. If you make a VTAX table, since height is a vertical thing, you want to use that as your velocity. That's the only part that affects the height. This part does not affect the height, and therefore this doesn't. You can't use the full velocity because some of that's horizontal, and the horizontal part doesn't help with height. You know the acceleration vertically. You have a time. You can use half the time. You also to do that. You also know the final speed vertically. Okay, vertical speed is just like if you're firing it straight up. So I'll leave it to you to do the rest of that. And then I want you to do these conclusion questions. The very last sheet that I attached, you don't have to do. So let me know if you have any questions. Hopefully this will be successful. And when you're done, you're going to upload everything, including that graph. So hopefully you can print that graph out, take a picture. If you can't, you might have to upload two things, the lab itself and then a separate upload of the graph.